All right, now let's talk about matrices. In our first week lecture, we talked a little bit about matrices, but we didn't exactly get into actual MATLAB coding of these matrices. If you remember in your first lab, there were some questions in there on matrices. I think it was in section 3. And you were asked to find a specific element of a matrix. I believe it was matrix A, element 1, 2. And it was in parentheses 1, comma 2. Now, that's a way for us to either pull information from an existing matrix or create information into a new matrix or an existing matrix. But let's take a look at this matrix here. Notice that there are 9 elements. There's 3 rows, which is at the top, in the middle, and the bottom, and then there's 3 columns. On the left, middle going down, and then on the right. And then on the bottom right of each one of those elements are numbers, 2 numbers. Those numbers indicate the row and the column. The first number is the row. Notice all 3 numbers on the top are 1, 1, 1, 2, 1, 3. That's the first row, first column, first row, second column, first row, third column. And then it's the same as you go down. If you remember, the fundamental unit that MATLAB uses is known as an array. Well, it's the same thing as a matrix. Just the numbers that we've used so far, for instance, when we define x as being 3, it's a 1 by 1 array, or a 1 by 1 matrix. This matrix is a 3 by 3. Now, the elements of this matrix do not need to be numbers. They can be something else. If you remember the different types of data that we looked at last week, the double data type essentially means it's a number. It could be an integer, it could be a complex number, but it's a number. Character is when we created text, right? If you remember, we put the color equals yellow or fruit equals banana, and we would surround that variable with single apostrophes. Let's do a quick example here. If we said fruit 1 was equal to banana. Well, this is not a double, right? This isn't a number, this is text. Because we used single apostrophes, MATLAB stores this data as a character. So if you go over to your workspace and you just hover over that little grid on the left side of the variable name, this is a 1 by 6 character. So the data type is character. And then the last one is logical. Logical, and we only did some short examples on this, is essentially when you ask MATLAB a yes or no question. MATLAB's going to respond with true or false. But the way that it responds is not with the words true or false, but with the numbers 1 and 0. But it's not the same numbers that you're used to as a double. It's a logical response. If the response is true, the answer is going to be logical 1. Whereas if it's false, it will be logical 0. Now, any different types of data can be put into a matrix. However, using the normal square brackets for our matrix, everything in that data set needs to be the same type. In a later lecture, in a few weeks from now, we will get into how you can combine numbers and text and logical types all into the same matrix. But for now, everything will be the same type. So let's take a look at this matrix again. The red box represents row 1. And you can see at the bottom right of each element, the numbers 1, 1, 1, 2, and 1, 3. The first number representing the row. And then in the orange box is column 1. It's the second number on the bottom right. So it's 1, 1, 2, 1, 3, 1. When we describe a matrix, we almost always describe it by its size. If you look at this matrix as an example, this is a 3 by 3. There's 3 rows times 3 columns. Okay? The indices for that are typically known as I and J. I and J represent which row you're looking at and which column you're looking at. If somebody says a m by n matrix, it typically means it has m number of rows and n number of columns. Where a m by n matrix is that size. If it's an n by n matrix, notice these variable names are the same. This essentially means it's a square matrix. It will have the same number of rows and will have the same number of columns. And then we looked at vectors, scalars, right? A scalar is just a number. Just a number is a 1 by 1 matrix. The vectors that we looked at last week, when we said x was equal to 1, 2, 3 in the square brackets, that's essentially a 1 by n matrix, or an n by 1, depending on if it is vertical or horizontal. Now what happens when we want to access specific information in here? Let's say we have this matrix A, and we can see that there are 2 rows and there are 3 columns, making the size of this matrix a 2 by 3 matrix. Now what if we wanted to access the 5? Looks like it's on the second row, second column. Okay? There's a few different ways that we can do that, but first it's important to know how MATLAB and the computer actually store this data. You may think it is 1, then 2, then the 3, then the 4, then the 5, then the 6. That would make sense. That's pretty intuitive. However, MATLAB stores data in something called column major order, which means the first element in A is the 1, but the second one is below it. It's going to go through the first column of data. So the second element would actually be the 4. Then the third and fourth element would be the 2 and the 5. And the fifth and sixth element would be the 3 and the 6, looking something like this: 1, 4, 2, 5, 3, 6. So if we asked MATLAB for the third element, we would say, okay, I want information in matrix A. So we would type capital A, and then we'd open parentheses 3. We can also ask MATLAB for a specific row and column. We want row 1, which is the first entry, column 2, which is the second entry. And that takes us to the same place, which is this number 2. Many of you in our lab this past week probably saw the equations in problem 5 and tried to duplicate them in MATLAB. And there were many times where I said, look, the notation that we're used to seeing as, math people is math book notation. Look at the equation at the top. X parentheses t is equal to v naught times t times cosine of theta. Now what this really means in a math book sense is that x is a function of t. T is the independent variable. X is the dependent variable. So x is just a function of t. The notation that we use in a math book is very different from the notation that we use in MATLAB. So many of you try to write something like this: x of t is equal to v naught times g times cosine theta. And it makes perfect sense, right? But let's see what actually happens when we try to type this out. So I'm going to clear the workspace. I'm going to clear the command window. And let's just take a look at the command window real quick. I believe in the problem statement for problem 5 in lab 1 was that t was equal to 5, 15, and 25. Remember, g was 9.81, alpha was equal to 72, and v0, I believe, was equal to 235. Let's just make sure all that information's there. Now, if we type this, we say v naught times g times cosine d, because remember, MATLAB will default to radians, and we want it in degrees, we would type something like this. Now, before we hit enter, ask yourself, how big is t? T has 3 entries, all in a single row, which means that t is going to be a 1 by 3. I'll come over to the workspace and we can see, yeah, it's a 1 by 3 double. Now, if x is a dependent function, sorry about this. If x is a dependent function on t, when we hit enter, it should be the same size. There should be 3 values for x because there's 3 values for t. But what happens when we hit enter? Whoa! How big is x? It's a 1 by 25. How is that possible? Well, here's what MATLAB's doing. MATLAB is taking the elements of x. So we're saying that the fifth element of x is when t equals 5. So this should be the first value. Then we're saying that the 15th element of x is when t is 15. And it does the same thing for when t is 25. But what happens with all of the other numbers? 1 through 4, 6 through 14, 16 through 24. Well, we're not telling MATLAB what they are. So MATLAB's filling in the blanks with 0. Oh, we can't have that, can we? So the proper way to do it, and now I'm going to clear the x, is we just get rid of this. There is a use for that, but it's not what we're after here. Oh, forgive me. The equation should be times t, not g. There we go. Now we get 3 values for x because x is a function of t. And now t and x are both 1 by 3 doubles. So in MATLAB, this nomenclature is assigning the tth element equal to the equation on the right. Whereas this is just saying x is a function of t. Now obviously in my equations here I put g, but just pretend that it was the t. All right, so here's a few different data types. We have a few variables that we've defined. We have a, b, c. Then we have a variable called comment. Now they're all different sizes. A is a matrix, looks like it's a 3-row by 4-column matrix. B is a 1 by 3, that's a row vector, and C is a 1, 2, 3, but it's a 3 by 1, it's a column vector. And then the variable comment is not a double. It's not a series of numbers or a single number. It's just text. Here it's the text hello, H-E-L-L-O. This is a 1 by 5 character array. So now we have 4 different types of arrays here. And if we want to access specific information on it, we can use the nomenclature on the right. For instance, if we wanted the element in A that's in the second row, third column, that would be the number 7. And this is how we would type it out. So the first row is 1, 2, 3, 4. The second row is 5, 6, 7, 8, and so on. And if we look at that second row, 5, 6, 7, 8, the third entry in that row is the 7. For B and C, it's a little bit more straightforward, right? We're asking for the second element of B, which is 2, or the third element of C, which is 3. Now, interesting for the character array, remember, a character array takes into account every single digit. It's not a single thing, it's 5 different things. It's the letter H, the letter E, the letter L, and so on. So if we wanted the third element in comment, we would say comment comment parentheses 3 and hit enter, and it would give us the letter L. Let's do a quick example. We said comment was equal to hello, and we said I want to know the second element of comment. That's all we have to type. Hit enter, and it will give you the letter E. All right, some matrix operations. I know we saw this a little bit, and a few of you may have been stumped a little bit when we got into the Lab 1 regarding matrices. But the very first thing to know about addition and subtraction is that the matrices must be the exact same size. Different from multiplication or division, but if we're just looking at addition and subtraction, they must be the same exact size. Now, if you tried in MATLAB to add matrices of a different size, MATLAB will give you an answer. It's not going to give you an error. It's going to force a result, but I promise you that result will be wrong. It is impossible to add or subtract matrices of different sizes. Multiplication. If you remember, there's a slick little trick that we learned last week where we said, okay, if A is a 2 by 3 and B is a 3 by 3, we need those inner numbers to match. That's the same as saying the number of columns in the first matrix must match the number of rows in the second matrix. So if you look at the two red boxes on the left, we're looking at the first matrix, which has 3 entries in the columns, and the second matrix has 3 entries in the rows. This is perfectly suitable. However, if we switch the matrices around, there would be 3 columns in the first matrix and only 2 rows in the second. So it would not be. If you need a little bit more help on how to multiply matrices, I suggest a quick Google search. We'll show you how to do it, or you can come see me during my office hours. Now we won't use the inverse too much, but looking for the inverse and the transpose in matrices can be very, very simple. For instance, the transpose is essentially just swapping the rows and columns of a matrix. And it's done with just a single quote. Now remember, when we used quotes before, we were defining text and there was a starting parenthesis or a starting quote and an ending quote. Here we're only using it one time. So we're not putting text in it, we're just adding a single quote after a matrix. And what it does is it takes the first column, which in this case is 159, and it makes it the first row, which is 159 along the top. Do a quick example. We can say capital A is equal to 1, 2, 3, 4, 5, 6, and we'll get into this semicolon on the inside in just a second. But here we have a 2 by 3 matrix. And if we wanted the transpose of this matrix, maybe we'll call the transpose B. We can say B is equal to A transpose, just a single quote. And you can see the only thing that happened is that the rows became the columns and the columns became the rows. Now there's something called an identity matrix. A lot of people will call it matrix I. Matrix I is almost always a square matrix, and the elements of it are ones going down the diagonal from the top left to the bottom right, and all of the other elements are 0. What makes it an identity matrix is if you use the matrix multiplication rules, any matrix multiplied by an identity matrix will be the original matrix. We have 1, 2, 3, 4 as our first matrix. Multiplied by an identity matrix is still 1, 2, 3, 4. So let's take a look at what that is. I'm going to create a square matrix. We'll say 2, 5, 6, 9. It would look something like this. Then we'll create an identity matrix, which is 1, 0, 0, 1. And if we say A times I will be an identity matrix. It's the exact same thing as A.